diagram illustrates the MySQL InnoDB Redo Logs workflow, detailing the journey of a transaction from the client to achieving durability and commit. Let's break it down step by step interactively. Step 1. Client sends SQL query. The process begins when the client sends a query, e.g. an insert, update, or delete to the MySQL server. This query signifies the start of a transaction. Step 2. Query execution. The MySQL server processes the query. It passes the operation to the InnoDB storage engine, where modifications are performed on in-memory data structures, buffer pool. Step 3. Redo log buffer records changes. InnoDB generates redo log entries, which describe the changes needed to redo the operation if required. These logs are temporarily stored in the redo log buffer in memory. Step 4. Flushing logs to redo log files. Periodically, the redo log buffer flushes the logs to redo log files on disk to ensure durability. Logs describe the changes necessary to recreate the transaction, even in case of a crash. Step 5. Sync redo logs to disk. Redo logs are synced with the disk using a sync operation. This step ensures that all log entries are durable before committing the transaction. Step 6. Request for commit. The client sends a commit request, indicating the transaction should be finalized. InnoDB verifies that the redo logs guarantee durability before marking the transaction as committed. Step 7. Transaction complete. The commit operation is finalized, and the client receives a transaction response. The process ensures that data changes are persistent and recoverable, thanks to redo logs. Crash recovery. If a crash occurs at any point after Step 3, the redo logs are used to recover uncommitted changes and replay committed transactions not yet written to the data files. This workflow highlights how InnoDB's redo logs ensure data durability, crash recovery, and high performance, even in high concurrency environments. Let me know if you'd like further clarifications.